So you want to build an AI that it's kind of like this. It patrols around the path. If it hears a suspicious sound, it goes to investigate it. If it spots a target, it chases it. And if the target gets out of sight for enough time, it goes back to patrolling. But somehow this only looks simple. And soon you are wrestling with Unreal perception system and behavior trees and state trees, and the implementation still feels clunky. Well, that sucks. Okay, let's get through this. I want to talk today about how to implement the most basic action game AI cycle, which for some reason seems to be super complicated in Unreal. And I don't know if it's because of the AI perception being very cryptic, or if it's because me and a lot of people that I see on the Unreal Slacker Discord and online on forums don't really start with what is the problem that they're trying to solve, but they jump into the tools, into behavior trees and state trees before even understanding what they want their AI to do. This is an error that I made myself, so I will try to show you how I fixed these things and how I came up with a very simple template that you can use for yourself, but I also invite you to design this, use this just as an inspiration, and then design it around your own needs. So at its core, we have these three states: default, investigate, and chase. Inside default, we wait, play an idle animation, we can go to a patrol path. Inside investigate, let's say we go to the last heard location. In chase, we straight go to the target and attack when we reach it, or whatever. The implementation doesn't really matter. The complexity is in the transition and how we inform the system, the state machine, because it's a state machine, that it needs to change state at what time. So let's start by defining what the transition should be and when they should happen. Everything starts in root, which is the entry point. No matter you are in state trees or behavior trees, everything starts from there. So the first actual state we consider is default. Default has a few transitions. Default can go to investigate when we have no target and we heard a sound. Default can go to chase if we immediately get a target. Then investigate can go back to default when we're done investigating, we have reached the last heard location, or if the target we're chasing is not reachable, we cannot reach it for any reason. Maybe it's not on the nav mesh, or it's above a ladder, whatever, there is a gap in between us. We don't want to be stuck, so we go back to default, actually back to root would be better. Investigate also can go to chase if we lock in a target. Now we start to see that we want to go to chase basically every time we have a target, no matter which state we are in, so I put that transition on root. Lastly, we look at chase. From chase, there are two transitions we want to have, and we have available. One is go back to root or default if we cannot reach our target, and two is go back to investigate. If the agent loses track of the current target for more than X seconds, we fall back to investigate the last heard location. Okay, and these are just the transitions. This is just what should happen. Now we need to define how all of this should happen. And for this, I'm using a separate task, a place where I can put some logic that keeps running and keeps checking the status of the world, in this case just the perception events, and it uses it to update some decision variables, and mainly here the current target and the last heard location. I added one more thing, which is fire decision events inside this update task. Since I already have these decision variables and I'm doing some logic with them, I straight away tell the state machine, well, now this event happened, so if you have a transition that requires that event to be triggered and go through that transition. But you could do the same thing, put in the same logic inside the transition itself without needing the event. And that frees you of the limitation of using state trees for this specifically. So what are we going to do in this task? Before we jump into Unreal, we will look at this. Because if you understand this logic on a high level, then you can find a way to implement it your own way and edit it and expand it according to your own needs rather than following which nodes I'm actually using to create it. So when the system starts, be it a behavior tree or a state tree, we hook up into the perception updated event from the AI perception component. Every time this component perceives something, it will send an event here with a structure that is full of useful information: the actor, the location of the stimulus, and whether it is successfully sensed. And this is going to be useful in a moment, as you will see. As soon as we get an update, we want to know which sense has triggered it. Is it sight? Is it hearing? Is it something else? We only need the sight and hearing here. With sight, we really need to distinguish whether the agent caught sight of something or lost sight of or lost sight of something. That's a very important distinction. We want to do different things based on that. If something enters our line of sight, this Boolean will be true. And at that point, we can basically store the current target. We can update this variable at one condition, if we don't already have one. Because if we already have a target and this target is the same that we are receiving here, then no need to do anything. Optionally here, I also send the target acquired event as per what I've explained earlier. That's optional. If the sighting is unsuccessful, and we go through this path here, we want to enable this condition here to trigger this one here. We want to be able to monitor how long the target stays hidden from the chasing AI. So we start a timer. With X seconds, we define ourselves how many seconds we want to put on this timer. And when this timer expires, if in the meantime we have not caught sight of the same target again, then we set the current target to none. And optionally for me, I send the target lost event. But if in the meantime we get a successful sight event, then we want to stop the target. We want to stop the timer. And that's it. Because the other case is hearing. But for hearing, we already made an assumption, which is we only care about the latest heard location. So we can just keep overwriting the last location every time we get a successful hearing event. And that's it. If you can make this, you have the foundation of a solid action AI for yourself. And so here we are finally in Unreal to see the magic in action. Ta-da! Oh wait, I need to actually move my camera here, otherwise you cannot see the transitions. Here is the state tree that runs all the logic. The three states we discussed. This one has been named hasTarget because chase is actually part of the implementation, nothing fancy. As we discussed, hasTarget, we go there from root. Here there is a transition on this event. From default, we can only go to investigate if we hear a sound. And actually added a guard here if we actually have a target. This is basically irrelevant. From hasTarget, we get out of here when we receive the target lost event, meaning when the timer has expired. Let's go back with the camera now. Now, the big part of the logic, as you know, is in a separate task, which in this case is an evaluator. Why an evaluator? Because I can do things when the tree starts. I only want to listen to perception info updated events when the tree starts. There is no need to bind to this event any other time. And here we do what we said we would do. We switch on sense. I created two functions, one for sight, one for hearing. And what they do is check that the sense is actually sight or hearing in that case, and do the things that we said we would do using the information from the stimulus. So successfully sense, true or false. In case it's false, we start the timer. If it's true, we set the target or we stop the timer. And hearing is as simple as updating the last heard location and send the relevant events in my implementation. Now, this is one way you can go about it. I actually recently checked the new content examples that come out with Unreal 5.6, and there is a state tree which does pretty much the same things in a different way. If you want, and if you're interested, we can go through that in another video, and I will show you the differences between that and my approach. We can discuss trade-offs, pros and cons, but anyway, hey, I figured out this was worth sharing. Here are my 2 cents, and I will see you at some point. Bye!